Hi everyone, in this video I will show you a simple tool that I designed for my learning about hexapodes and kinematics, everything. I will be creating an hexapode robot, so as first steps I'm experimenting a little bit with forward and inverse kinematics just to be sure that after that I can continue with the project. So in this video I will show you that tool that I've created. Now this is a simple tool that just shows a leg of a possible hexapod that has three degrees of freedom, one rotation, like maybe like this will be better. As you can see, this is the rotation angle. After I have another rotation angle like this, and another one like this. So with this tool I can experiment a bit with the forward kinematics, and I will show you how this is coded so you can do your own. Okay, now I will explain a little bit my code. I will start with some structure of the code, and after we will go to the forward kinematics model. Here I have the liberation rotation. I'm using matplotlib to create the 3D plot. Here I have some definitions of the robot. For example, here I can configure the length of every part of the robot. After that, we have some definition of the plot with their sliders to be able to control it, and the forward kinematics model, and after here just some handlers when the sliders change. I need to call some functions just to be applied in the graph. Okay, so let's start with the forward kinematic model. Here we have the three parts, one for each point. We have the point 1, the point 2, and the point 3. For the point 1, we just have a rotation and a translation operation. Here we have the first translation. We need to translate the length of the coxa into the home position, the home coordinate. Okay, we have a simple matrix, translation matrix, so we apply it, and there we have our translation done. After we do the rotation, and we have our point 1 translated and rotated. Okay, for the point 2, we have the same, but 2 times, because it's applied like, let me show you. Okay, for the first point, we have just this translation and this rotation. For the second one, we have this translation, this rotation here, and also this translation and this rotation. And for the third one, we have this translation, this rotation, translation, rotation, translation, and another rotation. So it will be 3 times. Here we have on the point 2, we have the first translation, the first rotation, that are the ones for the femur translation and femur rotation. Once we have that ones, we can start with the coxa ones. The coxa and the first angle. And we have our point 2 translated and rotated 2 times. Here we have 4.3. It's the same principle, translation and rotation, translation, rotation, translation and rotation, and we end with our point 3 calculated. So I will show you another time the 3D plot, and we will play a little bit. Okay, it's not working. Okay, fine. I'll put it here. Okay, here we have the first angle of rotation. As you can see, it rotates 360 degrees. We will let just here, it's fine. Okay, now we have the second rotation, the femur one, and it can also rotate 360 degrees. We will let like this. Okay, can play a little bit. And finally we have the last one, the tibia ones, and as you can see, you can play with it as you want. And with that model you can put your final position where you want, playing with that angles and controlling it. Okay, and that's pretty much. I hope the code is interesting for you, and I will let you know the link to the code in the description. Okay, goodbye, have a nice day.